How you doing today, guys? Welcome back to another day of 7th grade math. This is Mr. Gomez, your favorite teacher in the whole world, and today we're going to be talking about area of composite figures. Before we start, please subscribe, turn that notification bell on, and let's ride. Alright, so area of composite figures, and it says right here, I can decompose a composite figures to solve for the area. What does composite figure means and how is that gonna look? Well, a composite figures is a shape made out two or more different shapes. Okay? And then you put them together and that's how you get a composite figure. So over here we have different formulas that we're gonna be using throughout this assignment or this video. Since we're only gonna be talking about area, some of the shapes that we're going to be talking about are going to be triangles, and we have the area right here. However, I like to write it like this most of the time, base times height divided by 2. That makes more sense to me because we don't like fractions. And then we also have the area for a rectangle or a parallelogram. That's just base times height. And then we also have a formula for a trapezoid, and that's going to be half base 1 half, then you're going to multiply that by the base 1 plus the base 2, then you're going to multiply by the height. We're going to rewrite this formula like this. Base 1 plus base 2, we add that, then we multiply times the height, and then we divide by 2. This is how I like to, anytime there's a fraction like a half, is the same thing as divided by 2. And then we have the circle formula, which we cover plenty on the previous lessons or previous videos, and we wrote this like radius times pi, and let's not forget that pi equals 3.14. Okay, so these are the formulas that we're going to be using throughout this video or this lesson, and we have something right here. So it says area of a rectangle or a parallelogram. Remember, these two right here, one of them is a rectangle and the other one is a parallelogram. So we're going to use the formula for the rectangle, which is just base times height. Okay? So this one is pretty easy. So, area, rewrite it, base times height, which is just 8 times 5, which is 40 inches squared. Finding the area of a square, pretty simple. And then just putting a big 40 right there. It's going to make sense a little later. And then the next one is the same thing, same formula. It's just a shifted or a tilted rectangle as a parallelogram. The 4 sides, 2 sides are parallel to each other, top and bottom, and the 2 sides. However, the 2 sides are shifted, and that's okay. It's still 4 sides is a parallelogram. And this is again same formula. Area equals base times height, which is 6 times 12, which is 72 inches squared. So this area is 72. All right, so now we're going to look at a trapezoid. The bases. All trapezoids have 2 bases. Something to keep in mind is that the bases, they're parallel to each other. Parallel, that means they never touch. Even if they continue, they will never touch. So all parallelograms have 2 bases. So that's the first thing that we have to do. And then the height is always a straight line between the 2 parallel bases. The distance between the 2 bases. So again, the formula for this area is base 1 plus base 2. Then we're going to multiply this by the height, and then we're going to take half of that. Okay? So in this one, we have the first parallelogram on the left. We're going to use that formula. So area. Yes. So the 2 bases, again, what are the 2 numbers that are going to make up my base? Remember, they don't touch each other. What are my 2 bases? What 2 numbers? 4 and 8. Very good. These are my 2 bases. Base 1, base 2. And all I got to do is put them on the formula. So area equals base 1 plus base 2. We're going to add those, then multiply by the height, and then take half of all that. So base 1 is 4 plus base 2 is 8. We're going to add those two. We're going to multiply by the height, which is the distance between the two bases, which is 5. And then we're just going to take half of all that. So let's continue working over here. What's 4 plus 8? So this is 12 times 5, which is 60. And then we're going to half that. So 12 times 5 is just 60. And half of 60 is 30 centimeters squared. So this right here is 30 centimeters squared. Again, base 1 and base 2, they're the two bases. They never touch. So on the shape on the right side, there is two bases because they never touch. So what are the two bases for this one? 6 and 10. 6 and 10. Base 1, base 2. So this must be the height. I'm going to give you a couple of minutes to work on this one. All right. So on this one, base 1 is going to be 6 plus base 2 is 10. My height is 4, and then we're going to half that. So this is 16 times 4. Then we're going to half that. So this is going to be 64, and half that is 32 centimeters squared. So this right here is a big 32. Any questions so far? Sure. All right, we're going to move to triangles. Area of a triangle. Remember, the formula for this is just base times height divided by 2. Now, some of these two triangles, both of them give you more than two numbers. The thing that you got to remember, though, is that on a triangle, the base is on the bottom and the height is perpendicular. That means it makes like a L or a T shape. Okay? So when I look at this one, is this perpendicular to the bottom? No. So the 5 is not my height. This is my base. So is this perpendicular to the bottom? Yes. This makes a 90-degree angle. That's the height. So on this one, I don't care about the 5. So this is just going to be base times height divided by 2, which is going to be 4 times 8, and then half that. So this is going to be 32, and half that is 16 centimeters squared. And the one on the right side, we have 4 numbers. However, which one's the base? 5. The 5. Very good. And which one is the parallel line to the 5? I mean, perpendicular line to the 5. 7. Very good. This right here makes a 90-degree angle. That means we don't care about the tens. So this is base times height divided by 2. 7 times 5. Half of that. So this is 35. And half of that is 17.5 centimeters squared. So we covered so far rectangles and parallelograms, trapezoids, triangles. What do you think we have left? Circles. So right here, circles. We have full circle, half circle, or semicircle. This is also called semicircle. And then a quarter of a circle. And remember, the formula for this is area equals radius times pi. We know pi equals 3.14. But that's only going to be, just like that, is going to work for this one, for a full circle. And what do we need? Do we need the radius or diameter? Need the radius. So we need the radius. If we don't have the radius, make sure you get the radius. Now, let's look at the full circle. We already know how to do full circles. Radius times pi. We don't have any numbers on this, so we're just going to talk about it. Now, what about a half circle? Can you still use the same formula? Yes. But if it's half a circle, what do you think you're going to have to do at the end? Divide by 2. Use the same formula, but then divide by 2. So what about a quarter circle? what do you think you have to do? Divide by 4. Use the same formula, then divide by 4. Notice, on a quarter circle, the distance given to you should always be the radius, because that's all they're going to be showing on a composite figure. So now that we know how to do rectangles, triangles, trapezoids, and circles, we can actually look at one of the composite figures on the next page. A composite figure is made up 2 or more shapes. We can find the area of a composite figure by finding the area of each shape. So the steps to solve a composite figures. Very good. So steps to solving a composite figures. First, identify or name the shapes that make up the composite figure. 2, label and or find the missing psi values needed for each shape. Very good. Number 3, write the formula. Very good. Find the area and then add or combine the area of each shape to get your final answer. So those are the steps. Identify or name the shape, label and find the missing side values, then write the formula for each shape. Find the area of each shape and then add them at the end. So in this case, over here, so in this one right here, it looks like a step right here, a staircase. So we can kind of break this into 2 different shapes. And we can break this one into 2 different forms. So we can kind of break it right here. And then we have this one right here and this one right here. Some of you will do it like that, and that's fine. Some of you will break it over here, giving you a large one right here and then another one right here. Which one do you do? It does not matter. I'm doing this one. Yep. So if I look at the pink, and what shapes are this? Let's name them. What shape are this? The first one, the pink one, is a rectangle. What about the green one? Also rectangle. So what are the formulas for the area for the rectangle? Very good. Base times height. Both of them are rectangles, so both of them are the same for this one. Now we're going to plug in values. So let's start with the pink one. If I look at the pink one, do I know the 2 numbers that I need to know? Yes. So A equals, what's the base? 30. And the height is? 18. So how do you find the area for that? What do you do? 30 times 18, which gives us 540 feet square. So you can put a big 540 right here. So far, so good? Now, let's look at the green one. Because I don't know everything about the green one. I only know the base. You're going to do 27 divided by 2, no? No, we're going to do something a little bit different. So now, let's pay attention for now. We know the base. This right here, this is the base. But we don't know the height. The height is not 27. The height is not 18. So let's pay attention to this. I know the distance from here to here is what? 27. I know the distance from here to here is what? 18. Okay? I know the distance. Well, I can kind of see the distance from here to be also 27. Just like this right here, right? So let's look at this. Can I find the distance from here to here? How? This is 18 right there. All the way is 27. So how much more do I need? Huh? How would I find the yellow length? Very good. We're not dividing because I don't know if it's halfway. It might be more than halfway. If I divide it by 2, it's wrong. So this one, I know from here to here is 27. From here to here is 18. So that means that the difference is going to be what I'm looking for, isn't it? Yes, you got to be able to figure this down. This is going to be probably the most difficult part about finding the area. Finding those missing values. So again, you guys are right now. So 27 minus 18 gives us what? 9. So this right here is 9. So now do I have the base and the height for the green one? Yes. So let's plug it in. 24 times 9, which gives us what? 216 feet square. So to find the total area, what was the last step? Step number 5. Add or combine the two areas. So that's what we're going to do. We're going to add 540 and 216. And that's going to give us a total of 756 feet square. So you can also put 216 right here. You can also put 216 right there, and then just combine them too. That way it makes sense. If you label all the insides, you can just add them together at the end. Any questions so far? No. All right, let's look at, hold on. This one right here. This is the last one I'm going to do. Example C. The figure below is made of two semicircles and a what? A square. Even though it doesn't look like a square, it's a square. And what do we know about the square? It have even sides or the same length, right? So if this is 8, what is the bottom? 8. What is the side? 8. And what is the other side? 8. So for the square, it's easy right here. Area of a square is just base times height, which in this case 8 times 8, which is 64 meters squared. Now the other part is two semicircles. So let's think about it for a second. If you have this semicircle and this semicircle, if you remove the square, can you put them together and make one whole circle? Yes. Yes. So two semicircles with the same diameter, same radius. So you have to put two circles together. You can, because otherwise, remember, for the formula for the area of a circle, we got radius times pi. But this one only works for full circles. In this case, if you only have, for example, that shape right there, that is only showing half of a circle, what will you have to do once you find the area of the circle? No, we don't have another side. Let's scenario right here. Scenario. If you only see that right there, you only have the square and half of the circle. We already found the square, 64. Once you find the area for that half a circle, what do you have to do at the end? Divide by 2 because it's only half a circle. But in this case, the two halves make a whole, so we don't need to do any of that. That's just in case of. So in this one, is the radius given to us? Let's draw this circle on the side, right there. This is what number is that? Right here. What number goes right here? Wait, in the middle, 8. 8. And is that the radius or diameter? The radius. Diameter. This is the diameter. So if the diameter is 8, what's my radius though? 4. The radius is 4. Make sure you find the radius. So now we can plug it in. 4 times 4 times 3.6, 14. This is 16 times 3.14. And when we multiply these two, we get what? 50.24 meters squared. Now, what is the last step? Total area. We're going to add them too. So we're going to add 64 plus 50.24. So this is going to give us 114.24 meters squared. And I guess that's how you find the area of composite figures. Just a recap, we relearned how to find the area of rectangles, squares, and parallelograms, triangles, trapezoids, and circles. We use that knowledge to be able to break the figures, find missing lengths, and find the area of composite figures. I hope that you learned something today. If you did, give it a thumbs up. If you haven't, please subscribe and turn the notification bell on. And other than that, let's ride.